Another example of being able to find the surface area of solid resolution, we're going to have a pretty tame looking function, 2 roots of x, about the x-axis, and it's going to go from 1 to 3 for our domain. So remembering our formula that the surface area A is going to be 2 pi integral from A to B function square root 1 plus the derivative of the function squared. Okay, so that's like our length times our circumference, and then we have our dx. So we're going to start by finding the derivative. Start by going through and setting this to 2x to the 1/2 power. And then when we find the derivative, that's going to be x to the minus 1/2 power. All right, so that's our basic derivative rules right there. Right, and at this point, what we can do is we can substitute back in. So just trying to make it look like a normal negative 1/2. All right, that's about as best as it's going to get. We know the function, we know the derivative of the function, we know the bound, so let's get to it. This is going to be 2 pi integral from 1 to 3. We have our 2 roots of x square root 1 plus x to the minus 1/2 square dx. Be careful. When you do your algebra here, this is not going to become x to the positive 1/4. Remember, when you raise a power to a power, you're going to multiply those together. And so ultimately, this just winds up underneath the radical. And I'm going to factor out the other 2. All right, so I'm going to make this 4 pi. So we have a 2 and a 2, and that becomes 4 pi, square roots of x. And then this becomes 1 plus x to the minus 1 dx. All right, and again, we just multiply exponents together. Right? Now, this is the trick to being able to try to solve this one. All right. I want you to notice that these are both square roots. And because they're both square roots, what we can do is we can take the x or we could take whatever's under each radicand, or under each radical, excuse me, the radicand, and multiply those together. And so this is going to wind up being 4 pi integral from 1 to 3 square root of x 1 plus x to the minus 1 dx. Or if we distribute through nicely, this is going to be 4 pi integral from 1 to 3 square root of x plus 1 dx. All right, and just to make sure you understand how we get x plus 1, remember when you multiply this times this, that's going to be x to the first times x to the minus 1, which is x to the 0. And anything except 0 to the 0 or infinity to 0 is going to be 1. All right, so now we're going to go ahead and integrate, and this is just a regular old u substitution. Let's let u be equal to x plus 1. du is going to be dx. And so we get 4 pi integral from a to b instead of 1 to 3, square root of u, and instead of dx, we have du. We could just rewrite the square root of u, u to the 1/2. And now we can just integrate. So it's going to be 4 pi u to the 3/2 divided by 3/2 from a to b, or 4 pi times 2/3. So I'll just go step by step. So this would be 4 pi times 2/3. Instead of u to the 3/2, that's going to be 1 plus our x. Because remember, what x plus 1 or 1 plus x, I'll just write it as x plus 1, because that's what it was originally. Don't forget your 3/2 power, and that's from 1 to 3. All right, now simplifying this might be a little bit ugly, but not too bad. We're going to substitute 3, we're going to substitute 1. So we're going to get 8 pi thirds, 3 plus 1 to the 3/2 minus 8 pi over 3, 1 plus 1 to the 3/2 power. We know 3 plus 1 is 4. 4 to the 3/2 is going to be 8. All right, if you don't trust me, use your calculator. If you don't trust your calculator, then I'm not sure what to tell you. So this is going to wind up being 8 pi over 3 times 8. And then over here, this is just going to be 2 to the 3/2. Remember that trick that we did in the previous video? This is going to be 2 to the first times 2 to the 1/2. since 1 plus a half is 3 halves, or 2 roots of 2. So this is going to be minus 8 pi over 3 times 2 roots of 2. Right. And then finally, what we can do is we can factor out an 8 pi thirds. We can also factor out a 2, since both 8 and 2 have a common factor. So we could write it as 16 pi over 3. And remember, 8 is the same thing as 2 times 4. So I'm factoring this 2. I'm factoring this 8 pi thirds. I'm factoring this 2 and this 8 pi thirds. And what I'm left with is 4 minus root 2. Right? And that's the most simplistic but exact answer that I believe we can get out of this. Okay, so be careful at the end with your algebra. Okay, lots of algebra steps, none of them too rigorous, but just to make sure that you guys get down to that most simplistic answer, that's what you guys would do. All right, now another example, and this time be careful with the reading of this. So we're bound by the function f of x, 2x to the 1/3 quantity, but this time we're binding it about the y-axis, okay? And x is going to range from 0 to a half. All right, so that means a couple things for us, okay? One of which it means that what we're going to have to do is we're going to have to translate this thing in terms of y. All right, the other thing that this means is that when we're done with this, we're going to have to go through and switch the bounds as well. All right, so don't forget that we're going to have to change both the function itself, but also we're going to have to change those limits of integration to make those in terms of y. Okay, so let's get to it, guys. So first thing we're going to do is let's go ahead and write our formula out. Now our area is going to be equal to 2 pi integral from a to b f at y square root 1 plus f prime at y square dy. All right, because we want the function solely in terms of y. Let's get our new limits of integration in terms of y. So, and remember, if f of x is going to be equal to 2x to the 1/3, and we substitute 0 back in, so f at 0 is going to be equal to 2 times 0 to the 1/3, which is 0. And then f at 1/2, excuse me, is going to be equal to 2 times a half to the 1/3, which is equal to 1. All right, so our y bounds for this are 0 to 1. The other thing we have to do is we have to change this over to a function of y. All right, so this is going to mean that y equals 2x quantity 1/3, or y cubed equals 2x, or finally y cubed over 2 is going to be equal to x. All right, and so this is our function f at y. We still have to find the derivative of that. All right, so f prime of y is going to be equal to 3y squared over 2. All right, and that's not too bad. And at this point, guys, what we're going to do is we're just going to go through and plug everything back into our formula right here. Okay, now remember, this is in terms of y. All right, so if we do that, that's going to have that our surface area is going to be equal to 2 pi integral from 0 to 1. Okay, so remember we changed the bounds. Our function of y is going to be y cubed over 2 square root of 1 plus 3y squared over 2 quantity square dy. All right. Or if we were to simplify this animal, 2 pi integral 0 to 1 y cubed over 2 square root of 1 plus 9/4 y to the 4th dy. All right, so notice what I did. Square the 3, square the 2, square the y square, since they're all being multiplied together. Right? This is a u substitution problem. All right, and it might be helpful for us to rewrite this as 1 plus 9/4 y to the 4th, not square root, but y to the 1/2. If u is equal to 1 plus 9/4 y to the 4th, and we take the derivative du, that's going to be 9y cubed. All right. probably best if we just have y cubed and dy. And so this is going to wind up being du over 9 equals y cubed dy. And so now we're going to go ahead and substitute everything back in, right? We have a 2.5, so those are going to go away. I probably should have canceled in the previous step, but nobody died, so it shouldn't get me that bad. And so we're going to get equals pi integral a to b, u to the 1/2, and then du over 9. Right. Like several problems before, we're going to integrate and get a u to the 3/2 power. Okay, so we're going to get pi 9ths times u to the 3/2 divided by 3/2 from a to b. Substituting again and simplifying, this is going to be pi over 9 times 2/3. We know u was 1 plus 9/4 y to the 4th to the 3/2 power, right? And fortunately for us, we have a 0 and a 1, so that makes it a little bit easier to kind of manage this. Now we get 2 pi 27ths, and by the way, this should be from 0 to 1. 1 plus 9/4 times 1 to the 4th to the 3/2 minus 2 pi over 27. 1 plus 9/4 of 0 to the 4th to the 3/2. All right, now under here, this is going to become 13 over 4 to the 3/2. All right, so, or another way to write that, as we've seen several times already, is that this can be written as 13/4 times 13/4 to the 1/2. Right, so keep that in mind as you guys are trying to write these through, is that you're going to keep using this technique just because in every single one of these integrals, there just seems to be a radical expression, and then a u sub or some algebra kind of simplifies it, right? And then if we go through and try to simplify this expression, that's just going to be a 1 to the 3/2, which is just going to be 1. Okay, so this whole thing right here just becomes 1. And so we get 2 pi over 27 times 13/4 times the square root of 13/4 minus 2 pi over 27. Right? Now this is actually pretty cool. When we simplify this, all right, we know 13 times 2 is 26. So, and then, but we could just cross cancel this. That becomes a 2. But also, this expression can be written as root 13 over root 4 or root 13 over 2. All right, so with just a little bit more simplification, right, this is going to turn into 13 pi. We have the 27 and the 2, which is 54, right, times root 13 over 2, and then minus 2 pi over 27. So one possible answer for this, all right, and let me erase a little bit of stuff just to get a little more room here so we can write a nice answer that's legible. All right, so if you want to fast forward a few seconds just to save yourself some time of your life, then go for it. And just one more line just to make sure I have enough room to do this or enough space. All right, so one way to write the answer is to write this as 13 pi over 54. And then we could actually multiply the root 13 times and then 2 times the 54. So we multiply this, so we get 13 pi root 13, right? And then 54 times 2, that's going to be 108 minus 2 pi over 27. But of course, if we factor out the pi over 27th, okay, and notice that we don't have the 2 any longer from this, at least I believe, after we erased everything, this should wind up being pi over 27. And we know that 27 times 4 is going to be our 108. So this is going to be root or 13 root 13 over 4 minus 1. All right, and this should be our final answer for this. All right, now, of course, we don't trust it. We can always go to Wolfram Alpha just to verify. All right, but this is probably like the most simplistic answer that you can get out of this. All right, so we do have one more example that we'll work through, and we'll do that in our next video.